Hey guys, Matt here. I'm redoing episode 2 of CMake. If you want to see the original one, I'll link it down below. I'm going to try to make a much shorter, more concise, more information packed. Oh, a couple people mentioned that this could be better, and I agree. I'll give it a try. I'm going to try to show you as much as I can. Here in episode 2, we're going to reiterate the point of executables and how to do executables mainly on Linux, and we're going to start talking about libraries and how to add just static libraries and make your own. So what I've got here is a Linux console. This is Ubuntu. Let me just show you a nice executable, a nice clean way of doing C++. Starter point, template starter point on Linux specifically. I mean, it's similar on other OSs, but you're going to have to make some adjustments as expected. Let me see where I'm at here. I'm in the current working directory. I'm in my source. So I made a little demo project in here called trim, and inside of it all it has is a CPP folder, so we'll go there, and I've got a CMake and a main and another folder called build, which we can remove this command here to remove a folder. Be careful with this command, it's a little dangerous. All right, so vim main.cpp. Let's have a look at the code real quick. That's in our C++ class, and I'll just highlight it with my mouse here as we go. So all this does is it's a main that takes in arguments. So you pass in arguments when you run it. The program's called trim. So all it does is it just erases white space and new lines and tabs and stuff. I saw this code I was watching one of Javid X9's recent videos, great YouTube channel for C++ stuff. I was watching his channel and he had these functions and I was like, oh, let me test those out real quick. Here's the interesting thing about these little programs, especially on Linux. They're very easy to make useful. So normally you build your program, right? And then what? You just use it from its build directory? No, there's a little more to it. So let's go ahead and build it. So generally, the standard thing you want to do when building is you want to be in your source directory, of course, or in your project directory, and you make a folder called build. You can name it slightly different if we want, but it's kind of standard to name it build or out. And we'll go into that build, and this is where we're going to run our CMake command. We're going to run CMake on the previous directory. And the build directory is where we're already at, so we don't need to specify anything. But of course, shortcut for source, -S, double dots to just go back directory. The source is in the previous directory, which makes sense if we just made a build folder and went into it. But we're already in the build folder, so we don't need to specify that because it's going to default to the folder we're in. Very simple, very straightforward CMake build. And there it goes. It's off, it succeeded. Now if we do an ls and list the files in this folder, in this build folder, we get a make file, and we can take a look at the make file if we want. I'm going to use cat-n, and let's have a look. -n just shows all the line numbers right here in your console, and you can see this make file, very first line, CMake generated file, do not edit. So it makes your make files. I had the luck of being taught make files first. Most people do not, because make files are a little more complicated. But here's all they are. It's the comment line. This is a target, I believe. These are dependencies, and down below dependencies, tabbed over, would be commands. These .phonies are special configs basically for targets. There's not a whole lot else to it. I mean, there is a lot more, but I don't want to get too deep too quickly. Like, you can define things and you can call them later with the $, kind of like CMake. With CMake got some of their syntax from makefiles. You don't even need to know this makefile stuff because CMake is in front of that. But, you know, if you want to completely skip or just not go the layer above make, you can not use CMake. You know, there's also other ones like pre-make, and I don't know, there's a couple others. But, you know, some people complain that there's layers of stuff, and yeah, that's just the way it goes. I don't know what you expect. There's always going to be layers of stuff. Okay, so if we want to run that, of course we need to build it first. Running CMake does not build your software. It just configures your makefile, and your makefile, all makefile does is, well, make's not even necessarily C++ related. Make is actually just terminal related. It just runs commands in your terminal. But it is a little C++ related because I think they have some shortcuts built in for C++ related things. But make just runs stuff in your terminal. So it's just going to run all your build commands if you run make. And make, when you type make, it looks for a make file in that directory. It can be a capital or an uncapital M, doesn't matter with make files. When you type make, it looks for that make file and it runs a command. It runs a target. So you have different targets. When you leave it blank, it runs the very first one, the top one, which I think was the default. But you can go, well, I think they have help defined as a target, and help just does some console out stuff. And there you go. Valid targets for this make file. They've got all, clean, depend, list, install components, rebuild. Let's take a look at our CMake file. Go back a directory and let's just take a look at it with cat. How many lines do you think this CMake file is going to have? Well, it's only got 4. It's 4 lines. And you saw how big that make file was, right? So you could type these 4 lines and be done, or you could type up that entire make file. So that's kind of the work that CMake does for you as an example. And you know, we just looked at that make file, so you know how large it was and how complicated looking it was. This is simple. Line 1, a version of CMake required. Kind of need that, makes sense. Declare your project name with project. I just called this one capital trim. Add an executable. Give your executable name. Tell it what source it needs. It's obviously skipping a lot of special flags and stuff here, but if you're not super concerned with that, you just need something to run because you're actually working on something else. I'll talk more about that shortly. Okay, this one is new. And actually we haven't even got to it in the series yet, but this is a really great thing to add if you're using Linux because it just makes your life easy. All right, so this install, it wants a target. Well, you got to specify that it's installing targets because there could be multiple. Trim, and that's got to be in one of the executable names. This could also be a library. We haven't got to that yet. So it's going to install an executable. Where does it install it? Well, it needs a destination, and we're going to call this one bin. Why bin? Because it's a binary. Let's put it in the bin folder. That's pretty standard for Linux. Now, Linux is going to install, if I'm not mistaken here, based on your user preference. So let's do this. Let's go back into our build directory. Make sure our CMake's up to date. Let's go CMake, source in the previous directory. And then let's just run make and build our target. So what does this program do? Well, all it does is take in any junk you pass in command lines, and it removes all the spaces and spits out. Like so. That's all the program does. But if you want to run it, anytime you run it, you got to path it through this build directory and get to the executable, right? So that can be kind of annoying. You can make shortcuts and do all little special configs to fix that if you want, but that's really complicated. All you really have to do is put this install line and you're good, because then you can just go, well, make sure we're in our build folder here, and we are. You can just go make install. And it will build it, have an error because permission denied. This is trying to write to where your executables are stored on your Linux machine, which by default users don't have write access to. They only have read access to this. So you need super user do make install. This is going to prompt for an admin credentials, which might be you if you've made yourself that sort of person, or root access, I guess would be a better way to say it. And you just type in your password here. In that case, it gives you access to write, installs the project. There's no config for this one. We haven't got to that. And it says it installed it in user local bin, which is what I was going to go try to find manually. It's cool that it just says it here because that saves me time. So that's where it's going to install user local bin on drive. All right. So now I can go anywhere on my computer. I just hit change directory with no arguments, which is just going to take me to my home directory. You can see I'm at home. And now you would think I can't run trim easily. To run trim now, I would have to go into what, source, build. I need to go the whole directory path. There we go. There, like that would run it, sure. But do I want to have to type that the whole time? No, well, you don't have to anymore because now it's installed. It's just there. So you can just, no matter where you're at, you can just feed it commands. And you can do this with Linux programs or with C++ and Linux all you want. You can make little projects that just do little things and take in little arguments, install them, and they're ready at the drop of a dime. You just open your terminal and type things up. It's also great for data science. You can just pipe in your data file, for example. If you have something that processes a bunch of data, you could go whatever your file is, or whatever your program is, not necessarily trim. That's just the one I have in my example case. And then you pass in whatever argument you want. Maybe you have like a data.csv and your program knows how to handle this data set. It just wants the file. You would design it in the same fashion. You just obviously be a lot more complicated than this basic trim, but the CMake would essentially be about the same. You could do it like this. Now, also this builds in debug by default. And if you want it in release, which is going to be a little more faster and a little more optimized, getting into debug versus release gets into some CMake build type stuff. I don't know if it's worth quite getting into yet. It might just make it a bit more confusing. So I think we'll wait a little bit. But I just want to say that later in the series, I do already have an episode on installing. But it goes a little deeper than this and it gets a little more complicated. So I think this is a cleaner example of how to do the install. And it's going to get you going a little faster if you're just getting started and just kind of want to like make a little useful program. Yeah, just be careful, of course. C++ is a powerful language that can prearrange memory if you let it. So that's another contentious thing. It's like, how simple do I want to make this? Because, you don't necessarily want people that don't know what they're doing poking around, creating software with admin rights, because they could mess up systems. So, in a way, there's got to be a steep learning curve because you don't want to be, messing with critical processes when you don't know what you're doing. You're going to break something. So just be aware of that, I guess, and be careful is what I'm saying if you're new, and just double check that your program does what it actually is supposed to do. That's going down a rabbit hole. All right, so we've kind of heavily reiterated how to and gone over an example of just a very, very basic program, getting it up and running, getting it installed, and kind of making C++ useful with CMake and saving you a lot of time of all the overhead of build systems by just typing those 4 lines. So those 4 lines are the big takeaway, but obviously we want to talk about libraries really quick. The repo for this particular series is kind of way ahead, so I'm just going to do a quick little clean example right here, and I'll just talk through everything I'm doing. Let's make a static library in the most simple way with using CMake as the build system. So the first thing you need to know here before you even touch CMake is with C++, how do you make a library? Because you do all the code, and then the build system is what says try to make this a library. So we got to do the code first, and then we can configure the build system to tell it to try to make it a library. And it's really that simple. So let's make a new project here. I'm going to use makedir and just make a fresh directory, and I'm going to call it some live demo. In this piece of software, I'm going to make another directory called CPP for C++, and we're going to go into that directory. I've been liking to do this lately in my new projects, rather than source or code, just to name it the language expected. So in the CPP file, let's make our actual code. I think we can just open up a new file. Let's open up a main.cpp. Well, put on the brakes for a second. We're making a library here. We don't actually need a main for a library. There's no entry point that runs from top to bottom in a library. A library is functions that you call from your own main that you make somewhere else. So we don't need a main unless it's some sort of tester. So hopefully that makes sense, but let's do an example. So let's make the old adder library. Same deal, let's make a .h. It's a header file, so we definitely need pragma once here. We need to define the functions that we want. Let's go ahead and make a namespace here, just for the sake of good C++. And I'm just going to call this early math, just to keep it in my own little personal namespace of my math functions. That way I don't interfere with other people's accidentally. Because to go off on another thing that you'll run into some point, so I'm saving you time in the future probably. At some point, you will try to call a function and you'll get this weird error that says it's ambiguous and that there are multiple versions of it, and your code and compiler doesn't know what you're talking about. And you're going to spend about 3 to 4 hours searching on Google, asking everyone you know what the heck's going on and how do you fix this. And the answer is, well, you've got the function defined in multiple libraries. So you've included headers that have overlapping function names or overlapping variable names maybe even. And the way that you can make sure that that doesn't happen is you put them in different namespaces, or you make them really unique names, but some names just tend to get reused a lot. So if you put it in a namespace, then you're pretty well guaranteed not to be overlapping with someone else's code names or function names. In this way, we can make our function names very simple. So let's make an adder that just takes in any type and adds them together. Let's not take in any type. I don't want people add characters and stuff. That'll get weird. Let's just do integers and floats. So we're going to return an integer, and we're just going to call add, and we'll just take 2 numbers to start, integer A and integer B. Now I'm kind of skipping some standards here, so I'm just making the code a little bit more simple. We're going to make a float version too. Yeah, you could template this, Bonus points if you template it, make it all fancy and handle a lot of stuff. This is all we need for our header right now. This is all we're going to do. You can extrapolate and add as many functions as you want in your own library. You can also do classes that can instantiate and stuff. We're kind of skipping classes here and just going straight to making functions. So, okay, now that we're done here, let's just write this file out and quit with this command here in Vim. And now we should have that file there. We should be able to take a look at it and see what it looks like. And we just need definitions for those. So let's make an associated C++ file, adder.cpp. And in this one, we're going to go into insert mode, include the adder.h with double quotes. Since it's in the same directory, and just declare the namespaces on the definitions. The first one we have was the integer version, and it's in Merlin Math add, and it just wants the two variables, called them A and B, and we're just going to return A plus B. Nothing fancy here, and float will be very similar. Okay, and we can write that out and quit. Okay, so that's actually all we need. We've got a couple function definitions. Now we just want to build this into a library. So how do we command CMake to do that? No problem. Let's make a CMake file, and it's spelled just like this on the top level. And of course we need CMake minimum required version. I usually say 2.8. You're supposed to do a version that at least supports everything you're doing in your CMake file, because there's some stuff about it that you can't do till later versions and stuff like that, but you'll learn that later. So not a huge deal. Now we just need to know what's going on here. We need a project, of course. So let's put project, and I'm just going to call it Merlin Math, I suppose. And we need, usually you do an add executable here, but we don't have an executable in this case. We have just function definitions. So we're going to do, instead of the add executable, just add library. Just add a library. And it's very similar to the executable syntax from here. It just wants a name. I'm just going to call it Merlin Math, same as the project name. Doesn't necessarily have the same name as the project name, but this is how the library is going to show up. It's going to have this name. So Merlin Math is fine. That keeps it kind of streamlined. And then it just needs to know what source you're working with here. And well, we're working with only two files. One of them's a header, one of them's C++ file. And we really, actually, in this case, only need to compile the C++ file because it just has everything we need. And we'll see if we get any errors. That file is just called adder.cpp, and then we can write and quit. Now, let's go ahead and make a build folder and work with the CMake. Make dir build, change directory into build. Now let's run CMake with the source being on the previous level. We're already in the build directory, so nothing else needed if we're leaving it all default. There it goes. CMake completed without errors, so our CMake syntax is good and the files exist. But now let's see if the make file runs. So we type make and it builds a target, and you can see it says what it did here. Building an object, adder.o, linking static library, lib Merlin Math. So you see it takes the name that you put, Merlin Math, it puts lib in front of it. That's standard for Linux. Puts lib in front of it, and then a .a. .a's are static libraries. If you see a lib with a .so, it's a shared object. Also, those are DLLs in Windows, dynamic link libraries. They're shared objects in Linux and Mac. So .so is that. And you see we built it. So what do we do from here? There's nothing to run. It just has functions in it. Well, as we mentioned before, you need your own main. So for example, let's just go back a directory, another directory, get this terminal, and I've messed up my file directories a bit. I meant to be in source when I was creating some of those. So I'm actually going to correct that up and do it. And this is a way to move files around in Linux. If you want to learn it, I'll show that real quick since I'm doing it. And if not, you can skip forward a bit. Go into source. What's in my source? I have the timer demo and trim. I want the sum lib demo to also be in source, but I think that CPP there was supposed to be in the sum lib demo as well. Yeah, it was. Okay, so we're going to go move the CPP folder in the sub lib demo folder, and it just runs. So, this is a command that was probably built with C++. The way we did it took in some arguments and it did some stuff. You see, it took in 2 arguments and did some stuff. You can make your own programs that do that too. So now when we do an ls, our CPP's gone because we moved it some lib. Okay, cool. So So now what we want to do is move some live demo into source. And there we go. We've cleaned it up properly. It's now in our source where it was intended to be to begin with. Didn't have to drag files around and go through folders, all with command line. You can do this all with command line. You probably already know that, but trying to Mr. Rogers some code here. Okay. All right. So let's go back into some live demo, back into that C++ folder in there where we built all our stuff. And let's go just take a look at the library here. But obviously it's right here. But if anyone uses this library, they also need the headers. The headers basically say to your code, it's a declaration of things to expect. And this library here are the definitions. So sound familiar? You know, when you first learn C++ and they have you put the declarations at the top, that's these header parts basically. And when they have you make the definition somewhere else, well, that's all built in here. This is the definitions. That's all libraries are, is their definitions of functions. But you still need to know about the functions being declared, and that's where that .h comes in. So if we want to make another project and use this stuff, well, we just make another project and we just bring in this library. So check this out. Let's go back to directories, go back. Yeah, let's just make another project here real quick. And we're just going to call this test sum. We'll stick with our standards and make a CP folder again. And let's just make a main. And in here, if we want to use that adder, we can. We just need to include the header file and we need to link the library. The link in the library will come later, CMake. So we don't need to necessarily do that here, but we want to know what functions we can call. So that's why we absolutely need the header. Now, where is the header? Well, from a directory standpoint, we know where it is on this computer. So usually people make some folder called like external or libs or something, and they drag all the headers into it. Sometimes, or if you have project config that sorts that out for you and you don't have to do that, that's fine. Because if you're using most modern IDEs and stuff, they know where to look for a lot of your libraries just by their configs. So I'm kind of going very raw with it here, and you know, a lot of IDEs and package managers abstract this so you never need to know it. So just want to make that clear that if you never see this, that's probably why. But if we want to include that library, we either have to put it into this folder locally, put the header into here locally, or just path to it. And we know it's like what, back, let's think about this, back 2 directories. First one goes into this project, second back goes into source, and then we want to go into some live demo, and then the C++ there, and then the adder .h. That should be a path that works. But we'll talk more about this later and how to simplify this, because clearly you don't want to do this with all your headers. So when we get to the CMake, I'll address that and simplify it, because you can tell CMake where your library headers are, or where your include directories are. Let's make it a main. We're not going to take in any arguments, and we just want to simply use the library. So let's see if we can call it. Okay, the function name was add, so namespace Merlin math. This should allow us to call it. Let's return the value, so we should just see it in the command line. Obviously that should add up to 5. We know that our add function does that. We can go look at it in the header. The definition is not there, but generally if people do libraries in this way, then they usually have a comment telling you exactly what the function does if you can't see the definition by the header. But that should be all we need here to use our library. So let's just make sure it gets linked. This is where we need CMake again. So let's just make a CMake file, go into insert mode and do the standard. We're in a different project here. We'll just call it test sum. And this time we are making an executable. Needs to know about our main, of course. And we need to link in the library is super important. So how do we do that? Well, target link library. And now it needs to know what target. It's our target that we just declared up there with that executable. Sorry, this is libraries. And now we just need to feed it the libraries. Now, when you feed it libraries, it only expects the name. It doesn't expect the lib in the front. It'll sort that out automatically. It doesn't expect a .a at the end. It'll sort that out automatically. It just wants the library name as you exported it in your other CMake. So that way you don't have to worry about the lib at the front and the A at the end, just to simplify it. And this should work. Should. I know it won't work, but in theory, you've got the executable, you're linking the library. Why wouldn't it work? Well, it doesn't know where this library is. That's why. Now, doing an install with this library would solve that. It would know where it is because Linux would put it in the path where it knows where to find C++ libraries. However, we haven't done that. So if we want to use it in this custom special way, we have to tell it. And the way we do that is we go target library directories. I'm going to look that up. That's certainly wrong, but it's close. Target link directories. Same target. And then it just wants to know, okay, what directory are we finding these libraries that you're going to link later? Where are they at? So we need the entire path to that library. And we know that it's in our source folder. So we could go, use little shortcuts here. We could go CMake, source dir, and then let's see, that would be the top level of this project, or the CPP at least. Go back a directory, and that would be the project folder there. Go back another directory, that would be into our source folder on Linux here. And then from there, we know that it's in our some live demo folder, and then from there CPP, and then from there build, and that's where it should be. It should be right there. So let's add that directory and say we're going to find libraries there. Okay. Now, target link directories was not added to CMake until 3.13. So if you're using this, you need to make sure you change your minimum required to 3.13. And that's where this version comes in. You just want to make sure someone's running a version that supports what you're doing. Now, this should, in theory, work. We may want quotes around that entire link directory. Not sure, but we definitely need one more thing here, actually. We need to know if it's interface, public, or private. In this case, it is going to be, insert mode here. It's going to be private. Private just means that, make sure I explain this right. Okay. Well, I'm just going to read it off the page because I feel like I'm going to butcher it if I try to custom say it. Interface, public, private keywords are required to specify the scope of the items that follow them. So it's going to scope these items. It says public and interface will populate the interface link directories. Target. And so I'm guessing the private ones just don't. I think for most cases when you're making your own custom executable, you're going to want them private because you don't necessarily need to expose the libraries you're using. So private's going to be fine in our case. Kind of makes it a little more black box to the end user, I guess. All right, so we filled out our CMake, we filled out our main. We think we got it linking correctly. Let's see if it builds. So we're going to make our build directory here. Go into that build directory, run our CMake command, source in the previous directory. Seems to be fine running that. Let's see if the make file runs. Makes with no errors. Whatever the case, I'm mighty proud. Well, if that linked correctly, then, and it built correctly, it should just run, and it should spit out a 5 because it's going to return 5. We did an add of 2 and 3, right, in the code. If it all works and uses the library, we should get a 5. I guess we need to either console it out or somehow hold the return value. So I guess we could go, does this work? No, that's just going to look at the binary. Hold on, how are we going to do? We pipe it in, right? Okay, we've got to go echo. I don't know. The value's just returned to the operating system. So I guess we could just do a console out. I was trying to avoid that. Be all clever. So let's include IO stream and just console out. Let's make it super clear in the code here. Put a new line character at the end. Let's still return the value. Actually, well, this return value is something different. This return value returns to the operating system basically as a true or a false in a lot of cases. So let's just return 0 for exit success. Actually, we can even use this keyword or macro. And we should be able to write that out and quit. And now let's go do the same thing again. We can just run make. We don't need to run the CMake command again. The make file stays the same since the files are still the same. If you add new files and stuff, then you need to regenerate. But if you just change the contents of one file, you typically don't need to regenerate. Your results may vary. All right, so make is fine. It built. We can run it again, and we should get some output. Yeah, so it pulled this 5 here from that library, which means we got everything correct. Very nice. So now I was saying that what if you don't have an exact path to your library? Maybe you're getting it off the internet or something. So you might want to link it and use the header, or you probably want to build it and then link it and use the header. You typically don't want to, well, take this for what you will. On Linux, at least, you typically want to build your own stuff. But on Windows, you'll see like, oh, here's a pre-built x64 version of the lib, and here's the headers. So you don't get to see the source. The definitions of everything's hidden in that library, and then they just provide you with the declarations, the headers to go with it. So a lot of libraries are closed source, and that's how they do it. But open source ones, you can typically pull down, build your own, link it on your own. And hopefully you're starting to understand that by watching the series, because that's kind of the big takeaway of, at least in part of this series. But ultimately we've got this awkward ... specifications for where it is. So basically what we're going to do here, well, you could copy it in to your project and just kind of make it local to your project. That way you don't have to do all that. That's what most people do. But I just want to show you another option that kind of expands on the workflow we've been working with. This is somewhat of a standard Linux workflow. So let's get out of this and let's actually go back to our library. So go back to our source dir, go back to some live demo, and let's just work up this CMake a little bit now. This is where the fun begins for Linux. Now, if we just go install targets, and we know our target already, and we need a destination. This one goes in live. So this does get into a bit of a rabbit hole. I'm just going to pull this over and talk for a second about this. We're only looking at normal libraries. All right, you see there's object, interface, imported, alias. They have their uses. I don't personally use these ones as much, so I'm not familiar enough to talk about them a ton, but I think they're other specific cases. And most of the time, I believe you're just going to be using so that's what we're going over. If you want to know more, check the documentation and make sure the version you're using supports what you're working with. But ultimately here, what we need to know about add library as well. We want a name. We already took care of that. We need to put static or shared. And there's other stuff here too, but we're pretty much only going to do static in this example here. I've never messed with modules, so I don't even know how to explain it without doing some research. And then ultimately we're going to need the source and optionally this exclude from all. We're also not going to get into generator expressions just yet. I will at some point though, they're very useful at times. Okay, modules are linked at runtime. That's something I would like to explore sometime. I haven't really gone into that too much. I think we'll stick with static. I was just thinking of maybe showing shared, but I think we've covered enough already. We're going to stick with static. If no type is given explicitly, the type is static or shared based on whether the current value of the variable build shared lives is on. So you can set this build shared lives to true or false when you configure CMake. Let's make sure we get it installed. Install is important. Let's install this thing. Okay, install targets. We're going to go with destination live here rather than bin. And we also need to put the headers in here as well. Okay, so we can kind of pack this all into one command, but we need to make sure the library knows what headers it uses. So the way we're going to do that is with set target properties. And just referencing here, so we put in our target name for what target we're setting the properties of, and then properties keyword here, and then public header keyword, and then your .h files. Now with that, we can go on this install, we can go library, destination. Well, we want that to go into live. Your path might be different, but with Linux, it's just live. And then we also want on this install the public header destination. So we got a library destination and public header destination for this target. And you want this to be your include path. I believe in Linux, it's just going to be include. And you might do a subfolder of your project name. Maybe we'll do, but this is all one command. I've just broke it into multiple lines. That one needs an underscore. All right, let's give this a try. Let's write this out. Let's go into our build directory and try it again. We'll go CMake, source the previous directory, give it a try. Get some confusing stuff, doesn't match the cache, rerun with a different source or directory. Well, we can just delete everything in our build directory. That should take care of it. And from here, we should be able to run clean CMake command. And there we go. Now we should be able to go make install. Let's see what happens. We've got an error of permission denied. That is expected. Just need to super user this. Sudo make install. What's our password? And there we see that it did the install. Local live, there it's in there. Local include, it's in there. We can go back to our other program that uses the library now, and now we can adjust accordingly, because we could in theory, these local files for working on it, those aren't necessarily going to be there, or maybe someone will clone this test somewhere else. So we can't rely on this structure to be like that. So since we did the install, we don't need to rely on that structure anymore. So let's edit our CMake. And now we can get rid of all this link directory because it already has a link directory. Just Linux is going to have that. It knows about that path already. So we can just link it. It also knows about the headers already. So we don't need to do a special header directory either. Let's go back into our build directory and just regenerate this thing. So we are going to do another clean here of this directory. And then we are going to rerun our CMake. Now we can go make and just make sure it builds. It builds. If it builds successfully, that's good. It means it found the library and it also found the headers. So our edits and our expectations of it knowing where they were correct, thanks to the OS handling some stuff for us. And now we should be able to at last run it. And we get our result. Looks fine there. So it seems to be working. And that's pretty much it. I think we're done with this episode. We've went over a lot. We've went over how to make an executable, how to install the executable on your computer and just run it from your command line at any time, how to make a library, how to install the library. Now, if we made a C++ program anywhere on this environment, we could just use this library we created without having to specify any special include directories, without having to specify any special link directories, because they're where they expect. Well, take it easy, guys. Keep coding. Reach out to me if you need to. I'll be around. Best way is through Discord and through the Patreon, or through the business email if you got business stuff for code tech tutorials. All right, peace out.